Deduplication with watermarks. In streaming applications, it's common to encounter duplicate records due to retries or network issues. Spark structure streaming allows for deduplication using the dropDuplicates operation or specified columns, unspecified columns in conjunction with watermarking for time-based data. This ensures each event is counted once, enhancing data accuracy, especially in windowed aggregations where late data can lead to incorrect results. Watermarks serve as a guideline for how long the system should consider a window open for late arrivals, allowing the deduplication process to be more effective over time. I would like to demonstrate how deduplication works in the code. So the simple way of doing this is using dropDuplicates, which is one of the standard methods that you can just use from the streaming API. And if you do this, then let's say I have a data frame here. I just want to show you guys what the data looks like. So this is my test data, and I'm going to try to deduplicate so the users won't appear multiple times. So I'm saying that those are duplicates, and I only want to see one instance, one row of each user. So if I go back to deduplication and I run this, and first I will run it without the deduplication so we can see what the output is. Let's just see, so dedupe, and that's the other way of doing it. So let's just first dedupe the simple way. So if I run this, it's going to show me all the records that are in the test data because I didn't deduplicate. So let's see. So what the code does here is it gets the data from the test data, and then sorry, that's the wrong one. It gets the data from the test data, and then it starts streaming in a pen mode and writes to the console. This is just to show us what ends up happening, what rows are retained and what rows are removed. So as we can see, all rows are there. There are multiple instances of the users. Okay, so now I will deduplicate, and let's see what happens now. I will rerun this. And let's see if it removes the duplicate users this time. So that's just displaying the original test data. And let's see, the next one should be, okay, so the next one is the output that comes from the streaming, where it writes to the console. As you guys can see, it removed the duplicate users. So now there are situations when this is not enough. So as you guys can see that even if I remove the watermark, you would think that watermark 1 minute, if you consider the fact that some of these records are outside the 1 minute boundary, you should see some of these records there because they're outside the watermark. For instance, let's just look at Joe, for example. Joe has records 5 minutes apart. So one would think that those records are not all of them are removed, since I am using a 1 minute watermark. So let's see, I remove the watermark, even I remove the watermark, and if I remove the watermark, I get the same thing. So basically, watermark or no watermark, all the duplicate users are removed. Now, in some situations, that's not what we want, right? We might just want to remove duplicates in a narrow band of time, or we might need to do other things to it, to the stream. And in this case, what we can do is there's another method called mapGroupWithState. What mapGroupWithState does is that it allows you to create a function, and that function will get a group key and an iterator of the event records, and you just pretty much do whatever you want. Like in this case, I am picking the last record, the last event record. That's how I deduplicate. And I'm also taking, so I created a user state structure, which is a case class. So user state, unique event count, last event in group. So I'm passing, so I'm getting an iterator of the event records, and then I get the count of the unique events and then the last event record. And I create a user state with this, and I return this. And if I return this, this is going to become a part of the output, a streamed data frame. So let's see what this looks like if I run this one. So again, the difference here, the crucial difference is that I really do whatever I want here. So I can have a very custom way of processing. I'm going to run again, and let's see what it does now. And moment of truth. Okay, that's just displaying the test data. And then let's see, our output is, this is our output. So I actually, I can actually stop it here, probably. Oh, it's actually, you have to use update. Another thing I need to mention, that because this second method requires aggregation, so there's a group by key. Once you have once you have aggregation, and aggregation is required for map groups with state. Once you have aggregation, you have to use update. I even put a comment here that you can't use append because you have aggregation. So that's why it's actually stopped. It doesn't keep trying doing it because it's no longer changing. It already did the aggregation, and this is the output. And when we stream an aggregation, it will only, in update mode, it will only update the output when the aggregation changed, when the aggregation keys and values changed. Okay, so as you guys can see, it put out the username and the unique event count, which is what I specify up here. When I, let's see, where is it? When I return when I return the user state, updated count, and the last event are the two things I'm outputting, and that's what shows up here. The updated count and the last event. The last event is for Dave is this one, and the last event for Joe is this one. So that's all. These are two ways of doing deduplication. I would add that if you guys want more performance, Spark structured streaming has an option of using the RocksDB. RocksDB is just for performance enhancement. RocksDB doesn't change the functionality. So I put a comment here. I was just looking for it. So I put a comment here. You add this configuration to the builder, and then it's going to use RocksDB for this kind of thing, for this kind of state computation. So for the method map groups with state is going to use this RocksDB, and the advantage of this is that it's going to manage state very fast. Spark structured streaming does not give you access to RocksDB. It's all happening underneath the hood, and it's transparent to you. It just happens behind the scenes, and all you see is speeding up the result. This is unlike other streaming platforms such as Flink, where you can interact with RocksDB directly. That's it. Thank you for listening. Subscribe if you like the content. Thank you.